Mm.
Okay, let's see if we have people joined in. Okay, we seem to have one person. Maybe let's wait for a few more minutes and then start off. Okay. Okay, we still. Let's see how many are there live now. Okay. Okay, we can start now and yeah. So yeah. Uh, Hi guys. So this is the video that we are making for the assignment 2 for the artificial intelligence course. So yeah, this will like we are just trying to help you get speeded up on the assignment. We'll give you some idea about the code base, that how the code base is structured, and what all you need to do. So yeah, that's it. Let me start with the presentation. So yeah, this will be me and Ramya presenting. Okay, and we are taking the slides from Trace and Mukundan who presented last year the same content. So credits to them. So, as part of this video, we will be covering bunch of things. One is administrative details, the submission deadline and all of that, then installation, the project structure, how do you do the testing and submission on Gradescope, and then we will be open for questions on the from the YouTube video or on Piazza as they are. Coming to the administrative details, the assignment has been out for a few days now. Hopefully, we see that there are some of you who have already started, and there are some who are just recovering from or still working on the assignment one. Hopefully, that should be done by tonight. So, yeah, you guys should get started on the assignment too. This one is due on September 22nd, 11:59 p.m. UTC minus 12, anywhere on Earth time. So keep a note of that and ensure that you submit your best work before that. For this assignment you can make unlimited number of submissions, but there is a with the constraint that you can submit only twice every 30 minutes. So this is slightly a lenient thing compared to what you had for assignment 1. So hopefully that works out well. Coming to the next part, installation. So you shouldn't need to do much to get this done. You just need to go to the Git repository, go and clone it locally, and you can use the same environment you had created for assignment 0. So you can just do that, and you won't face any other issue. Now coming to the next part about the project code and structure. So
Let's go through the GitHub repo. So we have a folder called resources, which has papers related to bidirectional A star, bidirectional UCS, and the terminating conditions. This will be useful for the last few exercises. And then we have few files related to the graph data Atlanta and Romania. Then the submission.py is the main file where you will be modifying the methods, and this is the file you have to submit to Gradescope. And then there are a few test files called search submission test grid, search submission test, and search unit test, which you can use them to locally test your search methods. And let's go through the main one, submission file. So the first section is a warm-up section where you implement a priority queue and UCS.
You do three basic algorithms in addition to the priority queue implementation. You do BFS, you do your UCS, and you do A star. We'll walk through those in order. So
Yeah, the first one, the priority queue. You need to implement view methods, the pop and the append method, and uh, this will be used as a frontier queue in the search algorithms.
you need not put in way too much effort into this. This is like one of the very beginning part for this assignment, and further you can use build write code on top of the HipQ library that we have that Python provides, and we have also provided a link to one useful page in the GitHub repository that you can look at. So
One thing to keep in mind is the FIFO property of heap.
yeah, so the HipQ version that Python provides that does not have the FIFO property enabled. So you would need to do some tweaks to do that. We have also shared a page regarding that, so which should help you do that. And again, we would recommend that you do not spend way too much time in this. Like even though this is a very interesting part, but this is not the main focus of the assignment. The major meat of the assignment comes in later. So yeah, save your energy for that.
Yeah, you can modify the remove method, and you can add in your custom methods which you would want to use in the other search algorithms. And this is the first warm-up section. The next one we have is breadth first search, where you'll be given a start node, goal node, and an object to the graph class, which you can use to get the neighbors of every node. And we want you to return the optimal path from start to goal using BFS. So you need not consider weights in this algorithm. And one important thing to keep in mind is to sort the neighbors before inserting them to the queue. But this is because we want to return the
So
same path every time we run the BFS.
So generally, what the graph structure would return as the neighbors is a dictionary, and it is not deterministic what order they would be returning. Just so that the order in which you explore the nodes is similar to everybody else, and the also similar to the way we grade it. It would be highly recommended that we would highly recommend that you sort it before you add the nodes to the frontier. So yeah.
Yeah, one more important point is that the terminating condition of BFS is slightly different from the other search algorithms.
So
Um,
keep a close watch. Like you would see that at multiple places what the terminating condition is, and we have had questions regarding this on Piazza, so you can also go through that to get a better idea. So yeah.
yeah, you will be graded not only on the path you return, but also on the number of nodes you are exploring. So you need to explore the minimal number of nodes.
Yeah. So
And the next section we have is UCS. So this is similar to BFS, but it considers the edge weights. So you can get edge weights using the graph object. You can call graph.getEdge weight method by passing the start and by passing the
passing the two nodes, and you will get the weight of that particular edge. If you are able to go through a BFS with slight modifications, you should be able to go through UCS as well. So
and yeah, the terminating condition will be different from BFS.
yeah.
So the next section is A star. Again, this is similar to UCS, but we will include a heuristic which will be Euclidean distance.
Yeah, like A star is slightly different than the earlier ones in the sense that A star is more of an informed search compared to the earlier ones, wherein like as in case of UCS, you could see that you are just expanding radially and forming a circle, whereas in A star you try to determine where the goal is and try to expand more in that direction compared to the other directions.
Yeah, so major difference will be the number of nodes explored will be less in A star compared to UCS.
Yeah.
The path should remain the same. Okay, that's all we have for the warm up, and the next exercise we have is to implement bidirectional UCS search. So this is different from the traditional search, as in we start a search, simultaneous search from start and goal, and
So
and we stop the search when we reach an intersection point or when we reach the goal.
yeah, to simplify it a bit, like why this functions better than the normal UCS algorithm is, instead of having one giant circle expanding and trying to reach out, you will have two smaller ones that you will try to intersect. So another thing to note here would be like keep understand the terminating conditions properly, and that will help a lot in getting the best path in the optimal way, because that will ensure that you explore optimal number of nodes and not more than that. So get a good understanding of that part as well, of the terminating conditions.
Please go through the resources. There are terminating conditions mentioned for UCS, bidirectional UCS, and for A star. The next section is bidirectional A star. This is similar to bidirectional UCS. Um, you'll be using the same heuristic function, Euclidean distance heuristic, and the terminating condition pretty much remains the same.
But if you are able to do bidirectional UCS, you should not face much of an issue going for the A star part. It would be pretty much similar. Then this is kind of the higher things that we are looking at for this assignment. These are slightly research based topics, the tridirectional searches. So yeah, in this case, now this is slightly an upgrade over the bidirectional UCS that you did, that is there earlier. In now here you will have three nodes that you need to cover in a single path, and all the three of them um, would be expanding their frontiers and trying to reach out to the other two nodes.
Yeah, so this is different from three bidirectional searches, as in when we start from node A, let's say we are covering three nodes A, B, C. If we start from A, our goals will be B and C, and similarly, if we start from B, our goals will be A and C.
Yeah.
So each search will try to find the two other goals, and when any of the two searches meet, then you can stop that search and continue with the rest of the searches.
Yeah, please ensure that you do not use three bidirectional searches that will not let you submit. Like your submission would fail in that case. So please ensure that. And
For terminating, we can either terminate once we find two of the paths, or we can find three paths and find the minimum of those two and return that path.
so play around with the terminating condition and see what works out best for you.
Yeah,
That way.
and the order of path doesn't matter. It can be from A. Suppose the two minimal paths are A to B, and B to C. You can return A to B, B to C, A to B, B to C, or you can return C to B, B to A. So the order doesn't matter. It should just cover the three nodes.
Yeah. And then the final thing is the upgraded tridirectional search. Again, this is in this one you would try to do slightly better than the tridirectional UCS. There are multiple approaches. One of them is the you can use tridirectional A star. Yeah. And again, the uh,
Or you can use tridirectional you can use the
landmark.
landmarks method. There's a resource provided for that.
And finally, you have the return your name function, like is a single easy point there for you. Write your name, and that will get you that point. Then you also have a custom heuristic. If you want to write your own heuristic and you don't like the Euclidean distance one, you could go for that. But remember to update the argument in the A star, bidirectional A star, and the other tridirectional upgraded method to your custom heuristic. For extra credit, we'll be posting more information, but just a basic outline that we want to give. So there is this method, custom search, where you would submit your the code that you want us to use for the race. In this, we would be running it on the Atlanta map instead of the Romania map where all the earlier exercises were graded. So you can submit your best part that you want to go. Like again, and this would be a two die only. You'll need to traverse only two nodes, unlike that three nodes in tri-directional. So that is another thing. You can do either you want your VFS, you want your UCS, A star, bidirectional UCS, bidirectional A star, or something totally different that you feel would be the best. You can submit that, and like you will get extra credit based on that. And yeah, so next
So
we can go.
for local testing, we can use the search submission test and search unit test file. Search submission tests have some basic tests related to priority queue, append and pop, and then one more test to test the FIFO property. And for the other search algorithms, we have few test methods where we can specify the start node and goal node for the Romania map, and we can even visualize the path which our algorithm is returning. Yeah, so that's it for this search submission test. Search unit test um, has methods which search for path between every possible pair of start and goal node of
The
Romania.
Romania map, it will basically permute all the possible start and goal nodes. And but for the Atlanta map, it I think covers only 10. So beware. Another thing is you might running the unit test might freeze your machine. So beware of to change to make some changes or reduce the number of nodes, or maybe even disable the Atlanta map testing before you run this on your local machines if it is not high-end hardware. And yeah, that was largely about the code structure. Coming next to the local testing. So yeah, as Ramya just covered, you can use this, but again, we would encourage you to create your own tests. Like,
One thing is that local tests are just testing for the optimal path, but they won't test if you are returning minimal number of explore nodes. So you can debug that using the explorable graph class, but don't forget to remove that when you are submitting the actual code.
yeah. So, and again, like this should be slightly easier compared to debugging and testing should be slightly easier on for this assignment since everything is deterministic, unlike assignment one where we had randomized versions of games. So this should make your life slightly easier. Then the final thing about grade scope being that you need to submit the submission.py file that you need to submit. Gradescope has been working okay for us. We had some hiccups, but hopefully it will let you if it will let you submit and grade your submission pretty fast enough. And yeah, another thing similar to assignment one, you can view and download your previous submissions, and also you can mark which submission you want as the final one using the activate button. Yeah, again, as always, please start early. Gradescope does get busy. There might be load issues that might come up, and then similarly, even Piazza gets too busy during the last days. And considering that many people start late, Piazza gets flooded with doubts. And since there are around I think 14 of us who are TAing, it will be difficult for us to reply back to you at the faster during the later time. So yeah, start early, get your doubts solved early. That will help you. That will help us. Okay, and now we open for questions. If you have any questions, please post either on the channel or on post on Piazza. Let's. discuss some common things on Piazza. Mhm. So on Piazza, we had like since there are no questions, we thought we might just spend some time clarifying some of the common doubts that we had seen on Piazza. So there were many of you who faced issues regarding that you were able to pass the local test, but Gradescope was saying that oh, you are exploring more nodes or it is not optimal. So for exploring more, if Gradescope tells you that oh, you are exploring more nodes than required, we would recommend you to look at the explorable graph class and see how you can get the details about how many nodes you are exploring. Another thing that some of you didn't know was we do check, like you should not be exploring the same node twice. We keep account of that as well. You should explore every node only once. So in especially in the later parts for bidirectional and tridirectional, it will help if you if you build a cache for the neighbors of a particular node. And if you if also we would recommend to run the search unit tests as well, since they are more they test all the scenarios that can be possible. So we would recommend to do that instead of running just the search submission test. Or if you want, you can maybe try running some of the edge cases by modifying the start and goal nodes at the search submission tests. So, well, yep, since we don't see any questions here, we would close the live stream, but feel free to reach out to us on Piazza. We encourage you to to have discussions with your other classmates as well. So uh, make use of uh, make use of the community. We have, I think, around 500 people. Oh, we have a question. Okay. So, okay, we have a question that could you walk over the termination condition suggestions, especially for bidirectional and tridirectional search? So, yeah, the basic idea being that when like I'll start off with bidirectional and then go on to tridirectional. For bidirectional, you need to one very intuitive thing that you would try to do is that in both of the frontiers, if I'm looking at the frontier started by the start node, and if I find that if I see the goal node, then I will that would be my path. Similarly for the goal node, so that is one way you can get the shortest path. But the other way it would be that you well when you are exploring the start node, you come across that you're going to explore a node A, which has already been explored by the frontier starting from the goal. So that basically means that you have some sort of an intersection between the two frontiers, and that will be your sweet spot to return that. Now you have an optimal path from start to A and from goal to A. So merging those two will give you an optimal path from start to goal. If that helps. And so the idea similarly gets extended to tridirectional search, just that in this case you have three paths in the mind. Like if I say that the three nodes are A, B, and C, you will get one optimal path from A to B, one optimal path from A to C, and similar one from B to C. So while you calculate these and also look at the intersecting conditions, you also need to keep an eye on if the path from A to B and B to C, this combined A to C path is optimal compared to the three other possibilities that you have.
You will look for intersections from A to B. Let's say you are searching from A to B and C. When it's turn to search from A to B, you can look for from intersection between search from A to B and search from B to A. So if a node is already explored from a search from B to A, you can stop the search from A to B, and that will give your path, your overall path from A to B. but then you'd continue the search from A to C because it's tridirectional.
So essentially, you would need to find optimal. You'll need to find the triangle, some sort of a triangle that for all A to B, A to C, and B to C, you will need the optimal paths, and through that you can decide the optimal route that comes out, covering all the three. Do we have anything else? Okay, so we would wind up now. But yeah, as I mentioned earlier, do reach out to us for any of your other doubts or anything related to this assignment on Piazza. And we also have office hours scheduled, I think, almost twice every day. Please look at the Google Calendar for this course and see the timings for those, and join the office hours, and the TAs will help you get your doubts resolved. Yeah. Have fun solving this assignment, and please start early so that you don't get stuck at the end in a rut. Yeah. With this, we would close.